Okay, so we left off, we were doing a lot of problem solving. We did our mixture problems. We looked at it as adapted it for investment problems. And we did some other problem solving as well. Um, Even looked at the possibility of using systems of equations in those types of problems. So today I want to look at some more complex equations. Again, I know you've probably seen these before, but I just want to make sure that we're good with the fractions and decimals within our equations. And some other uses of variables that are a little bit different than what we've seen so far. So let's go ahead and just review solving equations. So if I have something like this, remember the key to solving an equation is to figure out how it was put together, how it was built, and then take it back apart. So this equation here, the variable was multiplied by 5 and then 7 was subtracted from it. So we're going to add 7 to get 5x equals 20 and then divide by 5 to get x equals 4. Now again, hopefully that's getting to be pretty much second nature for you guys. But it often confuses people when we change it to look something like this. Three-fourths x minus 2 1/2 equals 4 3/8. And looking at this, it looks a lot more complex. But really, it's the same type of equation as what we have right here. This equation was built by multiplying the variable by something and then subtracting from it. Same here. This equation was built by multiplying x by 3/4 and then subtracting 2 1/2 from it. So the process of solving it's going to be exactly the same. What's different is going to be the calculations because we're dealing with fractions. So here we would have to add 2 1/2 to get rid of the minus 2 1/2, and then we add 2 1/2 to the other side. So what's left over here is just the 3/4 x. Over here now we need our common denominator, which is going to be 8. So 4 3/8 doesn't change. This is going to become 2 4/8. 1/2 is 4/8. And so we'll go ahead and add. 3 and 4 make 7/8. 4 and 2 make 6. So 6 7/8. And of course, we divide by 3/4. So x equals, well, 6 7/8 divided by 3/4. We have to make the 6 7/8 into an improper fraction. 6 times 8 is 48, plus 7 is 55/8. And then we're going to multiply by 4 over 3, multiplying by the reciprocal. Cross cancel the 8 and 4, both divide by 4 to give me 1 and 2. 55 and 3 can't do anything. So 55 times 1 is 55. 2 times 3 is 6. And we break that back down into a mixed number. So 55 divided by 6. 6 goes into 55 9 times. That would be 54. So there's 1 left over. So it is 9 1/6. What I want to do today is I want to have you guys try some equations like this. Now this is a very basic equation. We're going to step it up a little bit because you guys seem to be pretty good at the algebra. So in your notes, I want you guys to try to solve this equation for me. One and 3/8 x minus 2 1/5 equals 4/5 x plus 3 1/3. Give that a shot in your notes. I'm going to give you a couple minutes and then we'll go. Let's take a look and see how you're doing. Anybody need an extra minute? Okay, let's take a peek. What would be the first thing I have to do here? First thing I'd probably get, see there's an x on each side, so I'd have to get rid of one of the x's. I usually go for the smaller one first, so I'm going to get rid of the 4/5 x. So I'm going to subtract 4/5 x, leaving me a 3 1/3 here. From the other side, I'm going to subtract 4/5 x as well. The only place I can take it from is the 1 3/8 x. So the negative 2 1/5 won't be affected. 1 3/8 minus 4/5 is, oh, what is that? 15, 55, 40th. 23 40ths, I believe, x. So now we have 23 40ths x minus 2 1/5 equals 3 1/3. We're going to add our 2 1/5. So 23 40ths x equals 5 8/15. And our final step, we'll divide by the 23 40ths. So we have x equals, now this is going to be a little bit of a long one. We got the 5 times 15 is 75, that's 83/15. Dividing by 23 40ths is going to be times 40 over 23. So I can cross cancel the 15 and 40. Divide by 8 to give me 3, or divide by 5 to give me 3 and 8. 83 times 8 is 664. 3 times 23 is 69. And we have to reduce. $69 does not go into 66. Let's try 9 times into 664. 9 times 9 is 54. 9 times 6 is, or sorry, 9 times 9, I get that wrong. 9 times 9 is not 54. 9 times 9 is 81, so 1 carry the 8. 9 times 6 is 54, plus 8 is 62, with 43 left over. So I'm getting 9 and 43/69. Show of hands, how many of you got that? Good deal, quite a few of you. And it shouldn't confuse us much when we throw in decimals. Something like this. Go ahead and take a minute and give that one a shot, and we'll go over it in a second. So let's see how you did. So here we've got items to combine here on the left side. 3.1 and 1.1 make 4.2x minus 4.2 equals 2.8x plus 2.1. We have to get rid of one of the x's. We'll subtract the 2.8. Make that go away. Leaves us with 2.1 over here. Subtracting 2.8x here gives us 1.4x minus 4.2. And then we'll go ahead and add 4.2. 1.4x equals 6.3. And then we'll divide by 1.4 to get x equals 4.5. How many of you got 4.5? Perfect. Well, let's step it up a notch. So in something like this, x over 7 plus x over 9 equals 32. Now the traditional way of looking at this, we say, well, x is divided by 7 and then x is divided by 9 again. But we've seen that division can be treated as multiplication by reciprocal. So we can treat the x over 7 as 1/7 times x, or x times 1/7, either way. And the x over 9 is 1/9 x equals 32. And now looking at this, it might look a little confusing, but we can tie this together with a problem like this. 3x plus 5x equals 40. In a problem like this, all we had to do is combine the 3x and 5x. And the same here. We have 1/7 x and 1/9 x. We just have to combine those. So 1/7 plus 1/9, working with our fraction, is 16/63 x equals 32. And from there, of course, it's simply dividing by the 16/63. So x equals 32 divided by 16/63 is 126. We can have something like this. So looking at this one here, some would go ahead and try to distribute the 6, dividing by the 6 or multiplying by a 1/6. But if we look at this, looking at our order of operations, this is a fraction bar, which tells us we do everything on top first and everything on bottom, and then we divide. The division is the last thing that happens. So if we're looking at how this equation was built, the last thing that was done in building this equation was to divide by 6. So to take it apart, the first thing that needs to be done is to multiply by 6, which is just going to remove the dividing by 6. Of course, we have to multiply by 6 on the other side. So it's now just 4x minus 2 is all that's left over here. 3 times 6 is 18. And we're going to simply solve the equation. Adding 2, 4x equals 20, and then dividing by 4. Get x equals 5. So now with that in mind, combined with what we were just looking at, I've got one for you guys to try. 2/3 x minus 1/4 over 7/8 equals 4/5. Try that one in your notes quick. I'll give you a minute to figure that one. Okay, so just like the last one, the first thing we're doing is we have to multiply by the 7/8 to get rid of it. That's gone. Multiplying by 7/8 over here is going to give us 7/10. So 2/3 x minus 1/4 equals 7/10. Add 1/4. 2/3 x equals 7/10 plus 1/4 is 19/20. And we divide by 2/3. Get that x equals 1/17/40. How many of you got that? Oh, a few less this time. Okay. That one's a little bit tricky. You're throwing in the fractions. Another application of these equations that we're going to look at is what happens when we simply have ax plus b equals c. And I still want to solve this for x. Well, if these were numbers here, the a, b, and c, it's pretty straightforward. It's actually kind of rather easy. We would subtract the b and then divide by a. Well, even though they're not numbers, we're still going to follow the same process. We'll subtract b, so we're left with ax here equals c minus b, is just c minus b. And then we will divide by a. Leaving us with just x here because the a is gone. C minus b divided by a is simply c minus b over a. Now, not all of them are quite that simple. We can run into some that are a little bit more complex like this. For example, we can have power is equal to I squared over R, current squared over resistance. We may want to solve that for R. So now what we're trying to solve for is on the bottom of a fraction. But what we can do is resort back to what we've done with our percents, with a simple proportion, and just put p over 1. Now this is a simple proportion. And we can solve it by cross multiplying. We're solving for r, so we treat that as our variable. We cross multiply in the other direction. 1 times I squared is I squared divided by P. Well, I squared divided by P is I squared over P. Or we could run into V1 over V2 equals C2 over C1, a concentration ratio, an inverse ratio of concentrations. Saying when the concentration increases, the volume has to decrease. And if I want to solve this for V2, just a side note, the 1 and the 2 here are not numerically significant. They're not a value. They're just signifying that this V is different from this V. Instead of having X and Y, different letters in there, we use V for both of them because they both represent a volume. But this is the first volume and this is the second volume. So anyway, to solve for V2, we're going to cross multiply. Again, isolating the V, cross multiply and divide by the third number. V1 times C1 is V1 C1 divided by the C2. And of course, the V2 is equal to that. Or you might run into something like this. We'll use, put the numbers in here for the first round. 5x minus 3 equals 2x plus, 2x plus 6 will go. To solve this, you see there's an x on each side, so we subtract 1. So you got 3x minus 3 equals 6, and then you add the 3 and divide by 3. We're not going to go through that whole process. But let's say that it looked like this. ax minus b equals cx plus d, and I want to solve for x. Well, just like up here where I subtracted 1 to get rid of it, I have to do the same down here. I don't know which one's bigger, so I'm just going to pick one. I'll subtract the cx. It's gone. So over here we just have the d. We still have the minus b. The question is, how do we combine ax minus cx? Well, if that were 5x minus 2x, we would just do 5 minus 2 is 3x. Combine the counts and keep the same name. Here we can do the same thing. A minus c is just a minus c x. Now finishing that up, it's just like any other one. We're going to add the b. So a minus c times x equals d plus b. And we're going to divide by the a minus c. So x equals d plus b over a minus c. So a few more variables to manipulate around there, but pretty much the same concept. The final use of variables that we're going to look at for today before we move on to ratios is we're going to look at variables as formulas or evaluating expressions. Now we're going to start out with a pretty generic formula or expression to evaluate, something like perimeter is 2 times length plus 2 times width for perimeter of a rectangle. So evaluate for a length of 15 and a width of 7. So there's no value given for P. That's what we're going to evaluate to find. 2 times L is 15 plus 2 times W is 7. So now it's just order of operations. Multiply first. 2 times 15 is 30. I'm going to cheat and do these on the same line. 2 times 7 is 14. And now we add 30 plus 14 is 44. So we get a perimeter of 44. Now since we're dealing with medicine here, let's use an actual medical formula. BMI is equal to weight divided by height squared. Now this is where weight has to be in pounds and height in inches, times 703. So let's say we have a person who weighs 180 pounds, has a height, let's say they are 6 foot tall, so 72 inches. Let's find their BMI. Well, W is 180. H is going to be 72, so that'll be 72 squared times 703. So in this fraction bar says do everything on top first, so there's nothing to do on top. Then we do everything on bottom, which will be 72 squared. So 5,184. Now that we have everything on top and bottom of that fraction done, we can divide it out. So 180 divided by, I'm going to use my answer function so I don't have to punch it in. So you get 0.03472 times the 703. Again, I'm not going to clear my calculator and punch it in. I'm going to leave it in my calculator and just multiply it times 703, so I avoid round off errors. You get 24.40941, we're going to say. That's a body mass index of 24.41. Another formula that we're going to use quite a bit, we're going to look at temperature conversions. If I have a Fahrenheit temperature and I want to go to Celsius, my Celsius temperature is equal to my Fahrenheit temperature minus 32 times 5/9. So let's pick a temperature. Let's do 80. Let's do a, how do I want to do this one? Let's do an 86 degree day. So 86 degree Fahrenheit is the day. What would that be measured in degrees Celsius? So we're just going to place F with 86 here, and order of operations takes over again. Inside the parentheses, we have to subtract. The 86 minus 32 is 54. Parentheses down to a single number, so we'll take them out and put in our multiplication. 5/9 times 54 is 30. So that is a 30 degrees Celsius day with 86 Fahrenheit. Another application we can run into, we'll do body surface area calculations. Calculate the body surface area. The BSA in meters squared. BSA is always calculated in square meters. So even if you're using inches and pounds, we're still just going to convert. It's going to be your height in inches times your weight in pounds divided by 3131. So let's take that same person we had up above, who has a weight of 180 pounds and a height of 72 inches, and plug them in. Get a body surface area. So 72 times 180 over 3131. Now, at this point in the course, I don't have a problem with you guys running these through the calculator instead of doing it out by hand. You're going to have to use the calculator for the square root here anyway. So let's do this. Square root of. Now, normally I'd have to put parentheses around everything on the top of a fraction. I don't have to here because it's multiplication, but I'm going to just because it's good practice. What gets done on the top of that fraction has to be done first, the 72 times 180. Then it'd be dividing by the 3131, and then we'll take the square root. We get 2.035 to round that off. So that person has a body surface area of just over 2 square meters of skin. Now let's throw out a challenge one for you here. on this one, solve for x. Take some time in your notes. We'll discuss it in a minute. Anybody have an answer yet? Or do you need more time? All right, let's take a look. First thing we have to do here, I mean, we could distribute and divide these out, make this 4/15 x plus 1/5 minus 2/9 x plus 1/3. Can you tell me why did this become plus 1/3? Because that's a negative and there's a minus out front. You have to distribute that negative. We could divide that out and get those fractions, but a simpler way would probably be to think in terms of least common denominator. 15, 9, 6, and 30, my least common denominator is going to be a 90. So I'm going to multiply this whole thing by 90. Now, way back up at the beginning of the day, we looked at that, x over 7 plus x over 9 equals 32. We could have done this same strategy there. Multiplied by 63 was the least common denominator and got rid of the fractions. So here we're going to multiply by 90. So 90 times this first section here. We got 90 over 1 times. And I'm going to put the 4x plus 3 in parentheses over 15. We can cross cancel. The 15 and 90 both divide by 15 to give me 1 and 6. So now 6 times 4x is 24x. 6 times positive 3 is a positive 18. So now here we've got 90 over 1 times, this is a negative 1 times 2x minus 3 over 9. I got to distribute that negative there. I'll treat it like a negative 1. So my first thing I'm going to do is cross cancel the 9 and 90, both divide by 9 to give me 1 and 10. Then I'm going to combine the 10 and negative 1 to make negative 10. And now I'll distribute it. Negative 10 times 2x, negative 20x. Negative 10 times negative 3 is a positive 30. Equals, but we still have to multiply by the 90 on the other side. So 90 over 1 times 6x plus 4 over 6. And again, we cross cancel. The 6 and the 90, both divisible by 6, give me 1 and 15. So 15 times 6x is 90x. 15 times 4 is positive 60. And finally, 90 over 1 times x over 30. Cross cancel the 30 and the 90 to get 1 and 3, so that is just a 3x. So, that was a mouthful in itself. Let's go ahead and combine like terms and solve. We'll work strictly on the left side first. So 24 and negative 20 are 4x. 18 and 30 is 48. Over here, 90 and 3 is 93x plus 60. We have to get rid of one of the x's. We'll subtract the 4x. It's definitely the smaller one. So 48 equals 89x plus 60. We will subtract 60. Negative 12 equals 89x. And finally, divide by 89. Well, negative 12 divided by 89 is just a negative 12/89 equals x. You can divide that out and get a decimal if you want to, but it's good enough just like that. Okay, we do still have a few minutes left, but that's really all I have to show you for today. So I'll give you your homework and let you take a few minutes to work on it. Out of your book, odd page 60 to 61. There's 1 through 47, the odd problems, which is on solving the equations with fractions in and using some of the formulas. Also on solving for letters rather than numbers. And also using formulas and evaluating expressions. On that same page, 61 through 65, the odds. Do a few of the word problems there. And then also page 67 through 68. We'll have you do 1 through 27, the odds there. Any questions? Okay, now remember, if you haven't, I've got a few test corrections from Medford. I noticed I had an email this morning that I need to get put in the book yet. Otherwise, the rest of you, if you make sure you're working on those test corrections and get those turned in to me. The deadline is usually just by the next test, so you have a couple weeks yet. Make sure you're working on those. We will not have class this Wednesday because WITC is in a district-wide in-service, so I won't see you all again until Friday. So have a great week, and we'll see you then.